So today I'm going to be doing the presentation on the glider fly-off. So to start us off, the name of the plane or the glider is the F2 Dart. So in this project I designed the glider, the F2 Dart, as an attempt to gain a greater level of knowledge about gliders. Therefore, I started building a glider with the intent of it traveling at least 20 feet. The requirements I was given for this glider involved it fitting within a 16 by 16 inch box and remaining intact for the entirety of the flight. Additionally, as it is a glider, it must have no form of propulsion and be powered purely by the act of being thrown and have no automatic system. So, with the first alternative, I chose elliptical wings to have an optimal amount of lift as I could possibly generate. I did likewise for the horizontal and vertical stabilizers in terms of shape, and this plane is smaller than the alternatives to reduce the potential for error when I'm designing wings, as it would be hard to make identical elliptical wings as compared to rectangular or trapezoidal wings. So the pros for this design would be an optimal wing shape and smaller builds, so less area to make errors. However, the cons would be the complexity of the wing design, as well as less area for the wings to generate lift with. This second design, with this iteration, I moved the wing placement farther forward as an attempt to move it closer to the nose, or to move the center of gravity closer to the nose where it would be on the plane, as well as an attempt to increase stability. Additionally, I moved the placement of the horizontal stabilizer slightly forward as an attempt to reduce the potential of them to be exposed on a failed test flight. So the pros would be a larger wing area, farther forward, center of gravity, or protected horizontal stabilizer location. However, the cons would be a large amount of material used in the body, which would weigh down the design. With alternative 3, change the shape of the wing to be a more simplified version to increase how exact or precise I could be with the wings. Additionally, I changed the width of the plane to make it easier to manufacture as well as lighter, and decided to take a more rounded approach on the nose of the plane as an attempt to reduce wind resistance. For the dihedral, however, it is flat as the wings are placed on top of the body, and therefore I was unable to actually get an angle as I was with the prior design. So the pros would be lightweight and easy to be accurate. However, the cons are somewhat less structurally sound than the others, as well as a suboptimal dihedral. So for evaluation initial concept, I thought my third and final alternative was the best option, as it would be able to generate a large amount of lift without a great deal of complexity, and I would not have to cut through the center of the body entering the wings. Even with the slightly less optimal wing shape and dihedral shape, I figured the accuracy that I could achieve would make up for any benefits I would receive with the other two designs. So for sizing, I ended up going with a larger glider to be able to get the longest cord possible to pick up as much lift as I possibly could. And I also lengthened the plane to make it as stable as I possibly could make it against side winds. So for the testing, the first and most immediate problem with my design was how heavy the back of the plane was. It caused the plane to do loops and achieve nowhere near the necessary level of stability to hit 20 feet, maybe going about 12 feet. My attempt to fix this the first time involved using tape, but when that weight wasn't enough, I tested taping coolant on the nose of the glider, eventually finding that a single penny worked best to counteract or to achieve the right center of gravity. After this was fixed, I was reliably able to achieve 20 feet or greater on test flights. The initial design was largely based on the third, with iterations of being changes being made as found necessary by the practical testing. So design iterations. I had numerous design iterations, with the vast majority of them related to either balancing the glider, with the others being made to increase how structurally sound the glider was. I had numerous iterations with varying weights at the nose of the plane, coupled with some form of counterweight, such as tape at the tail of the plane. Another thing, I received numerous iterations with the horizontal stabilizers as I changed their placement on the glider several times before sawing a cut in the back, allowing them to slide inside, ensuring that I would not lose them during the test. An additional proportion of the plane that received a great deal of iterations was the sanding of the nose to make the glider to make the wings, as well as the glider, or as well as the wings, as I continue to try and get a consistent level of sanding to reduce air resistance as much as possible. The final iteration successfully hit 20 feet. The glider flight off while maintaining the necessary requirements, such as side and lack of propulsion, as probably mentioned. This was the perfect fusion of prior designs, and I achieved a great weight and stability of this final glider. I used trapezoidal wings to keep weight down to maximize lift, with a similar thought process for the stabilizers. I also taped a penny of the nose with a thin wrapping of tape at the back as a counterweight. For adhesive, I largely used glue to connect the wings to the plane and used tape as a backup layer. I think it was essential that I had so many iterations, as each time I had a new iteration, I was able to improve the glider to strive for a more successful build. So the final specifications, as we see, the center of gravity is half an inch from the cord, and the calculated CL, as shown in the math, using the CL equals 2W over PV squared S formula is 3.002, with the final calculated CD being 16.3656 using the equation that was given to us. And you can see all the work in the bottom left corner. So for the video, here's the video of my test flight.
Alright, okay. I wasn't expecting that. Alright, okay.
And in conclusion, to conclude that I'm very proud of this final glider design as it turned out, as it successfully hit all the necessary requirements in my process of design, iteration after iteration, building the design and the testing and repairs that followed. I feel that I grew as an aerospace engineer and developed and improved upon various applicable skills, many of which do not directly relate to aerospace, like meeting deadlines and containing necessary deliverables in projects. My final thoughts are that I am very glad that I engaged in this project and developed practical skills that can be used in the workforce, as well as any other potential project I have to work on in the future. In terms of improving the design, I think the single biggest improvement would have been making the wing area larger, as increasing the size of the wings would have a negligible difference in weight compared to a much larger increase in lift coefficient. I also should have spent more time trying to get a better center of gravity as an attempt to make the glider not so top heavy, as I overcorrected for the initial back heaviness. And here are my references.